Hello everyone, welcome back to our discussion on the topic differentiation. Today we'll be continuing our discussion of quotient rule and we'll be treating mainly trigonometric function. Our first example is from UME 1998. It states that differentiate s divided by cos s with respect to s, and we are given the option. Firstly, we are going to write down our equation y will be equals to s divided by cos s, and since it is division, we know we are going to be using quotient rule, which states that dy over dx is equals to v du minus u dv divided by v square. Let u be equals to s and v be equals to cos s. So finding du, that's differentiating s, du will be equals to 1 and dv will be equals to minus sin s. Now substituting for u, v, du and dv in our formula, dy over dx will be equals to cos s times 1 minus s in bracket minus sin s divided by cos s in bracket squared. Simplifying further, it will be equals to cos s, cos s times 1 is cos s, plus s sin s minus s times minus sin s will be s sin s divided by cos square s. At this point, we are going to split our fraction into two, that's separating our numerator. It will be now be equals to cos s divided by cos square s plus s sin s divided by cos square s. Cos s divided by cos square s will be equals to 1 divided by cos s, plus we are also going to divide s sin s divided by cos square s. You will give us s sin s divided by cos s times 1 divided by cos s. Now recalling from trigonometry that sin s divided by cos s is tan s and 1 divided by cos s is sec s, we are going to be substituting sin s divided by cos s as tan s and 1 divided by cos s as sec s. Doing so, our equation becomes sec s plus s tan s sec s, or sec s plus s sec s tan s, and the correct option is D. Our next example states that find the derivative of 1 divided by sin s with respect to s. Now the first step, we are going to be writing down our equation y is equals to 1 divided by sin s, and since it's divided, we are going to be using quotient rule, which states that dy over dx is equals to v du minus u dv divided by v square. Next, let u be equals to 1, then v will be equals to sin s. Differentiating u and v, du will be equals to 0 and dv will be equals to cos s. Now substituting for u, v, du and dv in our original equation, dy over dx will be equals to sin s times 0 minus 1 times cos s divided by sin s in bracket squared. Simplifying our numerator, dy over dx will be equals to minus cos s divided by sin square s, because sin s times 0 equates to 0 and minus 1 times cos s will be minus cos s. At this point, we are going to be simplifying further by splitting it into cos s divided by sin s times 1 divided by sin s. And from trigonometry, we know that cos s divided by sin s is equals to cot s and 1 divided by sin s is equals to cosec s. Now substituting for cos s divided by sin s and 1 divided by sin s in our equation, our dy over dx will therefore be equals to minus cosec s cot s, or dy over dx will be equals to minus cot s cosec s. We have another example from LECO 2000 that states that differentiate with respect to s cos s divided by sin 2s, and we are given the options. Firstly, we are going to write down our equation y is equals to cos s divided by sin 2s, and since the functions are dividing themselves, we are going to be using quotient rule. Now applying quotient rule, which states that dy over dx equals to v du minus u dv divided by v square, we are going to be making our numerator to be equals to u, that is u will be equals to cos s, and our denominator to be equals to v, that is v will be equals to sin 2s. Now to get the u, that is differentiating cos s, when we differentiate cos s, our answer will be minus sin s, and when we differentiate sine 2s, that's getting the v, it will be equals to 2 cos 2s. At this point, we are going to be substituting for u, the u, v, and the v in our quotient rule formula, and doing so, the y over the s will be equals to sine 2s, which is v, times in bracket minus sine s, which is the u, minus cos s, which is u, multiplying in bracket 2 cos 2s, which is the v, divided by sine 2s in bracket square. Now simplifying further, it becomes minus sine 2s sine s, that's sine 2s times minus sine 2s, minus 2 cos s cos 2s, that's minus cos s times 2 cos 2s, divided by sine square 2s. And the correct option is E. Our final example is from NECO 2010. It states that the derivative of sine 3s divided by e raised to the power minus 2s with respect to s is. Now for our solution, the first thing we are going to be writing down our equation. So y will be equals to sine 3s divided by e raised to the power minus 2s. And obviously we are going to be using quotient rule, which states that the y over the s is equals to v du minus u dv divided by v squared. We are going to be making u to be equal to sine 3s, and v will be equals to e raised to the power minus 2s, which is our denominator. Now solving for du, we are going to be using chain rule or function of a function. Now we know that u is equals to sine 3s, and we are going to be making 3s to be equals to z. So saying let z be equals to 3s, therefore u will be equals to sine z. The z over the s will be equals to 3, and the u over the z will be equals to cos z. Now substituting for the u over the z and the z over the s in our chain rule formula, which states that the u over the s will be equals to the u over the z times the z over the s. The u over the s becomes cos z times 3. Now recall that originally z is equals to 3s. Now substituting 3s to be equals to z, our final answer becomes the u over the s is equals to 3 cos 3s. Now also we are still going to be looking for the v using chain rule. V is equals to e raised to the power minus 2s. Now we are going to be making z to be equals to minus 2s, and v will be equals to e raised to the power of z. Now according to our chain rule formula, we state that the v over the s is equals to the v over the z times the z over the s. Substituting for the v over the z and the z over the s, the v over the s will be equals to e raised to the power of z times minus 2. Now multiplying, the v over the s will be equals to minus 2e raised to the power of z. Recall that z is equals to minus 2s. Now substituting z to be equals to minus 2s in our equation, the v over the s will be equals to minus 2e raised to the power of minus 2s. Now substituting for v du and v squared in our original quotient rule formula, the y over the s will be equals to e raised to the power minus 2s times 3 cos 3s minus sine 3s times minus 2e raised to the power of minus 2s, divided by e raised to the power minus 2s in bracket squared. Multiplying our numerator and simplifying further, it becomes the y over the s will be equals to 3 cos 3s e raised to the power minus 2s plus 2 sine 3s e raised to the power minus 2s, divided by e raised to the power minus 2s in bracket square. Now our next step is that we are going to be factorizing our numerator. And factorizing our numerator, the y over the s will be equals to e raised to the power minus 2s in bracket 3 cos 3s plus 2 sine 3s. Now dividing our numerator and our denominator, that is dividing the e raised to the power minus 2s, because we have e raised to the power minus 2s in our numerator and our denominator. It becomes the 1 over the s is equals to 3 cos 3s plus 2 sin 3s divided by e raised to the power of minus 2s. Now, from our law of indices, we can bring our denominator to our numerator, but we have to change the power. So doing so, the 1 over the s will be equals to e raised to the power of 2s in bracket 3 cos 3s plus 2 sin 3s. We have some exercises for you to try your hands on, and for further study on this topic, you can check our Hidden Facts Further Mathematics textbook. You can easily get the hard copy, and if you would prefer a soft copy, you can get that at the website at the corner of the screen. Thank you.